Hello everyone, welcome to Chemazon-Complete Chemistry. So in our today's video, we are going to learn what is Nernst equation and we will also apply it by using an example. So let us first understand what is Nernst equation. So Nernst equation, it is used to find out the cell potential. What is Ecell? Ecell is the cell potential of any given cell at a particular temperature and pressure. Okay, so basically Nernst equation gives us the relation between the cell potential and the temperature. Okay, it gives us the relation between E cell, E0 cell or standard cell potential and temperature. So now let us write down what is the Nernst equation. So Nernst equation is E cell is equal to E naught cell minus 0. Okay, it is 2.303 RT upon NF log to the base 10 of Q. Okay, now let us write down what all these values mean. E cell is the cell potential. E cell is the cell potential. E0 cell or E naught cell is what? It is the standard cell potential. Okay, what is R? R is the universal gas constant. What is the value for R? We know it is 8.314 joule per Kelvin per mole. This is the value in terms of joule. Then we have T. T is what? T is the temperature. What is N? N is the number of electrons that is involved. Okay, that means the number of electrons lost during oxidation or the number of electron gained during reduction. Number of electrons exchanged. What is F? F is the Faraday's constant. Okay, what is Q? Q is the reaction quotient. It is concentration of product divided by concentration of reactant in the net cell reaction. Okay, of the net cell reaction that we will be writing. Okay, so there is one modification. Suppose we consider standard conditions. Okay, standard conditions means temperature is 298 Kelvin. Okay, you substitute the temperature is 298 Kelvin. R is what? R is the value that we have written 8.314. And Faraday's constant. What is the value of Faraday's constant? Faraday's constant is 96500 Coulomb per mole. Okay, and N is the number of electrons exchanged. So if you substitute the value of R, T and F, okay, the general equation that we get, we will be using it most of the times. The most important part is the temperature should be 298 Kelvin or in degrees Celsius it is 25 degrees Celsius. Okay, only if the temperature is 25 degrees Celsius, then we can use this equation. Okay, when you substitute this, what we will get? We will get E cell is equal to E0 cell minus 0.0591. This number you can remember divided by N log to the base 10 of Q. Okay, this is another form of the equation that you can remember that. But the important condition is that the temperature should be 25 degrees Celsius. If the temperature is not 25 degrees Celsius, then we will use this equation, the general form of the equation. Okay, so now let us understand this Nernst equation by using an example, a question. So this is a question that is given. For a given half reactions, the two half reactions are given. Their standard electrode potential is given. What we have to do is we have to first identify which is the cathode, which is the anode, write down the half cell reactions. Then we have to write down the net cell reactions. Okay, half cell reactions are given. We have to write down the net cell reactions. Then we have to find out the E0 cell. value of N and value of Ecell. Okay, so let us start now. So what we have to do is this reaction is given. Okay, so we have to solve this. First, we have to identify the cathode and anode. For that, what I told you, greater the value of standard reduction potential, more is the tendency of that half cell to undergo reduction. Okay, so the one electrode which has the higher value of E0 reduction potential, that is standard reduction potential, that will undergo reduction, or that will act as a cathode, because reduction takes place at the cathode. So which is the higher value? This is plus 0.34, this is minus 0.34. So now we can write down the half cell reactions at the anode. Okay, which is the higher value? 0.34. So this will act as a cathode and this will act as the anode. Okay, at the anode, zinc. Okay, zinc will act as an anode. Zinc solid will lose 2 electrons. It forms zinc 2 plus aqueous plus 2 electrons. Okay, this is what? This is oxidation, loss of electron. Then at the cathode, there will be gain of electron, that will be Cu2 plus aqueous. It gains 2 electrons and it forms copper solid. This is what? This is reduction. Okay, so first part we have completed, identify cathode and anode. Now what we have to do, we have to write down the net cell reaction. How do you write down the net cell reaction? Add the two half cell reaction. These are what? These are called as half cell reactions. Okay, add both of them. Before that, here you can see the number of electrons is same. If the electrons are not same, we have to multiply it by some suitable factor, and then we have to add both of them. Okay, but since here the electrons will get cancelled, we don't have to multiply it by any factor. So this will get cancelled, and then we can write down the net cell reaction. Zinc solid plus Cu2 plus aqueous. Okay, it gives Zn2 plus aqueous plus copper solid. Okay, so now, okay, so this is the net cell reaction. So the second part is also completed. Now here, how many electrons are involved? The total electrons involved are 2. So value of N, that is number of electrons involved, is 2. So we got the value of N. Now we have to find out the value of E0 cell. Okay, what will be E0 cell? E0 cell is E0 reduction potential of cathode minus E0 reduction potential of anode. Okay, what is the reduction potential of cathode? Cathode is the copper half cell. So it is 0.34 plus 0.34 minus reduction potential of anode, that is for the zinc it is minus 0.76. So add both of them, 0.34 plus 0.76. This will be how much? 0.34, 0.76. 0.17411. So 1.10. Okay, so the correct value of standard cell potential is 1.10. Okay, now what we have to find out is, we have to find out the E cell of the reaction. Okay, so we can find out E cell. E cell is E0 cell minus 0.0591. Okay, so here temperature is given 298 Kelvin. That is why I'm using this equation, divided by N, log to the base 10 of Q. Okay, now we have to find out the value of Q. Okay, we don't have the value of Q, so I can erase this. Okay, so what we have to find out, what is Q? Q is the concentration of products divided by concentration of the reactants. Okay, we have to find out the value of Q. Okay, Q will be concentration of product. So in the net cell reaction, if you have written that, it will be, what was the net cell reaction? It was Zn solid plus Cu2 plus aqueous giving Zn2 plus aqueous plus copper solid. Now here the concentration of the aqueous part is not given, so we will consider the standard concentration, that is 1 molar. Okay, so Q will be concentration of product. Now always remember, between solid, liquid, aqueous and gas, the order of the active concentration is gas greater than aqueous greater than liquid greater than solid. So always remember, whenever gas and aqueous are present, they are active concentration in presence of liquid and solid. So which are the active concentration? Aqueous species, that is Zn2 plus aqueous in the product. We will not write the solid term. Copper solid is inactive. Okay, active inactive means the active species plays an important role in the cell potential. This is 1 molar. This is also 1 molar. So this comes out to be 1. Okay, so what will be the E cell? E cell will be E0 cell is 1.1 volt minus 0.0591 divided by N. N is what? N is 2 into log to the base 10 of Q. Q is 1. Now we know log 1, value of log 1 is 0. So 0 into anything is 0. So 0.0591 divided by 2 into 0 becomes 0. So the final value of E cell is 1.10 volt. Okay, that is the final answer for cell potential is what? It is 1.1 volt. Okay, so we have found out E0 cell, it is 1.1 volt. Value of N is what? N is equal to 2. And what is the value of E cell? That is also same, 1.10 volt. I hope you have understood how to apply Nernst equation. What is Nernst equation and what are the different steps? First is we have to identify the cathode and anode. Next, we have to write down the half cell reactions and write down the half cell reactions in such a way that the total electron should get cancelled. Okay, if they are not getting cancelled, multiply a suitable factor. Okay, and then we have to write down the net cell reaction, find the value of N, E0 cell, and then we can find out the value of E cell. Thank you so much.